Okay, so Junior Roberts here. We're here with another physics worked example. This question here says, the figure below shows a scuba diver ascending from 20 meters below the surface where the water is 10 degrees Celsius to the surface where the water temperature is 25 degrees Celsius and the pressure is 101 kilopascals. Right, and here we have the diagram with the scuba diver, right, and he's actually ascending, as the question says, from 20 meters below the surface up to the surface, right, and it is said that the temperature, so at the surface, so we can say that the temperature here, the temperature T here, we can call that T1 is equal to 10 degrees Celsius, while the temperature at the surface, let's call that T2, is 25 degrees Celsius. Right, and we're told that the pressure at the surface is 101 kilopascals. Right? Now, this question here wants us to do a couple of things. The first thing that the question wants us to do is to calculate the pressure that the diver is subjected to at 20 meters below the surface of the water. And we are given that the density of water is 1025 kilogram per meter cube. So, to solve this portion of the question, we're going to look at the fluid pressure. Right? So, we know that a fluid will exert pressure on objects depending on the depth of the object in that fluid, right? So we actually have a formula which actually gives us a relationship between the pressure and the depth, and that formula is given as P, which stands for pressure, is equal to rho g h, where P is our pressure in pascals, rho, which is a Greek symbol, is our density in kilogram per meter cube, g is the acceleration due to gravity, and h is the height or the depth of the substance in the liquid or the fluid. So, using this formula here, we'll be able to actually determine the pressure that the diver is experiencing at 20 meters below the surface. So, we're going to say that P is equal to rho GH, and again, rho is taken as the density of water, and that's 1025 kilogram per meter cube. So, we'll have 1025 kilograms per meter cube multiplied by gravity, and again gravity is 10 newtons per kilogram, right, and our depth or height is given as 20 meters, so we'll have 20 meters, right? Now if we pull on the services of our calculator, alright, so we're going to take our calculator and we can say 1025 multiplied by 10, right, multiplied by 20, and this will give us the pressure that the diver is experiencing at 20 meters below the surface. So our pressure then now will be 205,000 pascals, or we can say it's 205 kilopascals. Alright, so that's our answer there for the pressure that the diver is experiencing at 20 meters below the surface. Now, if we go further, we see that this question here wants us to actually utilize the general gas law to determine, as a result of the rise, the ratio of the final volume to the initial volume of a bubble. Right, and again, this question wants us to use the general gas law. Right, so we're going to utilize the general gas law. Right, and the general gas law is essentially a combination of the three gas laws, Boyle's law, the pressure law, and Charles' law. And we actually have a formula that we use to express the general gas law, and we call it the general gas equation, and the formula goes like this. So we have P1 times V1 over T1 is equal to P2 times V2 over T2. Right, so we're going to use this expression again. This is our general gas law. Right, so our general gas law equation. Right, so we're going to utilize this to help us to solve our question. Now, again, the question wants us to actually find the ratio of the initial volume to the final volume. Right, so what I'll be doing is, first of all, let's look back at the question here. So what we're saying is that the diver, while he's at 20 meters below the surface, he will, let us say, release a bubble from his air system, and then that bubble will travel up to the surface. Now we want to actually determine the ratio of that initial bubble to the final bubble. So we can consider the volume of the initial bubble to be V1 and the pressure that the bubble experiences as P1. So let's write some values for the variables. So we're going to say that P1 is equal to, that would be the pressure at 20 meters below the surface, and we just worked that out previously, and we got 205 kilopascals. So our pressure P1 would be 205 kilopascals, right? And V1 is unknown, right? And also we can write the value for T1. So T1 would be the temperature at 20 meters below the surface, and that's 10 degrees Celsius. So because we're working with the gas laws, we have to ensure that our temperature is expressed in Kelvin. So we're going to have 10 degrees Celsius plus 273, and that gives us our answer in Kelvin, and that is 283 Kelvin. Right? Now P2 would be the pressure at the surface, and that's 101 kilopascals. While again V2 is unknown, and then because our temperature at the surface was 25 degrees Celsius, we're going to add 273 to that to get our temperature in Kelvin. So we have 25 degrees Celsius plus 273, and that gives us an answer of 298 Kelvin. Alright, so these are the values that we'll be working with to help us to solve our question. Now, if we use our general gas law equation, we will have again P1 V1 over T1 is equal to P2 V2 over T2. Right, so what I'll be doing here is to actually calculate V1 in terms of V2, so we can actually see the relationship between V1 and V2. So we can start by filling in our values. So P1 would be 205 kilopascals, V1 would be unknown, and T1 would be 283 Kelvin. So we have 283 Kelvin, and that is equal to P2, which is 101 kilopascals, times V2 divided by T2, which is 298 kelvins. Right, so once we have this now, we can go further to start to simplify this expression here. So to simplify, what I'll be doing is actually dividing. Well, what I'll be doing is to multiply both sides by 283 Kelvin. Right, so I will have 205 kilopascals times V1 divided by 283 Kelvin, and again I'm going to multiply both sides by 283 Kelvin. So I'll say 283 Kelvin is equal to 101 kilopascals times 283 Kelvin divided by 298 Kelvin, and again I will have my V2. Right, so once I'm in here now, I can pull on the services of my calculator. First of all, when I multiply this side by 283, I will end up with 205 kilopascals times V1 is equal to, and I can start to simplify this portion of the equation. So what I'll have now is 101 kilopascals, right, multiplied by 283 kelvins, right, divided by 298 Kelvin, and that gives us an answer of 95,916, and again we will have V2. Right, so we're starting to simplify the equation. So now we'll actually get a chance to see what the ratio of V1 to V2 is. Right, now because I have 205 kilopascals on this side, I'm going to divide both sides by 205 kilopascals. So I'll have divide by 205 kilopascals, divide by 205 kilopascals. So when I divide this side by 205 kilopascals, I'll end up with V1 equal this times V2. So I can take my calculator and I will say 95,916 divided by 205 kilopascals, and that gives me an answer of approximately 0.5 V2. Right, so what we're seeing is that V1 is equal to half of V2. So if I were to go ahead and actually multiply both sides by 2, so I multiply this side by 2 and multiply this side by 2, I will get that 2V1 is equal to V2. So therefore, the ratio, what the question wants us to find? The question wanted us to find the ratio of the final volume to the initial volume, right? Now V1 was our initial volume and V2 was our final volume. So the ratio of final volume to initial volume then would be equal to 1 to 2, right? Because again, V2 is our final volume and V1 is our initial volume. So the ratio would be 1 to 2. So therefore, what will happen is that as the bubble leaves the depth here and starts to ascend, what will happen is that the bubble will slowly increase its volume, right, until it reaches the top, and it will be 2 times its original volume. So again, this was Junior Roberts from realjuniorroberts.com. If there was anything in this video that you wish to get further clarification on, please post it down below in comments and I'll do my best to clear up any misconceptions for you. Like this video if it was helpful, and if you think others would benefit, please feel free to share so others will be able to get a chance to benefit from this video. Hit the subscribe if you haven't subscribed to this channel as yet, and hit the bell notification so you'll be updated whenever I post new videos like this. Thank you for watching.